Alright, here we go. We're talking about adding and subtracting real numbers, and real numbers, well, what are those? Pretty much all the numbers you've seen have been real, they haven't been imaginary. So if you've seen fractions, decimals, positives, and negatives, we even have irrational and rational numbers. These are all real numbers. So pi is a real number, pattern-like numbers, all of these is what we're going to talk about adding and subtracting today. So get this note sheet ready. Make sure you have the date and the title at the top and your name. And here we go. First, we need some notes. When adding and subtracting decimals, we line up place values. So I like to tell a story about what if I have a friend who has maybe $67,000, $67,987.89. And let's say he owes me $5. Well, what if he tries to just say, why don't you just take it from right here, why don't you just take 5 of these here pennies? Well, that's not quite going to satisfy me because that's not what we agreed upon. If he wants to change the place values, then I might as well, move it over here and take from his 10,000s. But that's not how we work. That's not how we do math. That's not how we do things. We know that place values are important. So if we're going to have to take away 5, we know we line up the place values so that we're adding tens with tens, ones with ones, and subtracting in likewise ways 10,000s from 10,000s or hundredths from hundredths. And so we would have to line up the decimals, and we'll just finish this one because why not? That's how much you would be left with. The second note is when adding and subtracting fractions and mixed numbers, we need like denominators. So maybe a way to demonstrate this is to say, well, what if you had 2/3 and you wanted to take away 1/2? So if you have 2/3 and you wanted to take away 1/2, well, you can't because you don't have a half over here. You don't have a half to take away. So what do we have to do? We have to cut these up into smaller pieces until it looks like what we want. We know that 2/3 minus 1/2. If we need like denominator, these both go into sixths. So 1/2 is 3/6, 2/3 is 4/6, and we'd be left with 1/6. Well, what does that look like? We'd just be making these sixths instead of thirds. We'd be making these sixths instead of halves. I can't believe it. I drew in 3/3. So what would this look like? It would look like this. 2/3 or 4/6. We could take away 3/6. We'd be left with just 1. We'd be left with just 1 right there, like that. Let's go on and see this last note. No matter whether you're looking at fractions or decimals, mixed numbers, whatever it might be, if we have positives and negatives, or if we think we need to follow the positive and negative rules. The first is to play add-ops if necessary to make sure you have an addition problem. The second step is to determine the sign of the sum. It'll be whichever you have more of. Do you have more positives, or do you have more negatives? Or do you have only positives, or do you have only negatives? Whichever is the largest value, that's the sign of your answer. And the third step is determine whether you're going to add or subtract values. So I tried to draw the beginnings of a little demonstration here. What if you had, I'm going to cross out half of this. So if you had 2.5, and we were going to add to it, let's make that a fourth. -4 and 1/4. We're going to still follow our adding and subtracting fractions and mixed numbers rules. We know we need like denominators, but we're still also going to follow these same rules that we use for positives and negatives. So we'll say, well, which do we have more of? We have more negatives, so I know my sign and my answer will be negative. Then we say, are we putting the same things together? Are we putting the same color algebra tiles together? Well, we have a bigger group. No, these are different, so we'll have 0 pairs, and we're going to cancel those out, or subtract is the easiest way to do that. So we know we're going to subtract, and then we could just do that, and we would get our negative answer. So you can see that even if you do have fractional amounts, you can still cancel out 0 pairs. And in this case, we'd be left with, what would that be? We'd be left with 1 3/4, -1 3/4. Let's check it real quick. That would be, we said we should subtract, so we'd have 2 1/4 minus, or 4 1/4 minus 2 1/2. 4 1/4 minus 2 1/2. We know it's going to be a negative answer. We already checked that. and we can say 4 1/4. Let's trade in one of these full units, and we would get 4/4. So we now have a total of 5/4 minus 2 1/2. 3 minus 2 is equal to 1. 5/4 minus 1/2, or 2/4. 5/4 minus 2/4 is 3/4, so 1 3/4. Negative 1 3/4 was correct. So let's move on. Number 1, we have 26 54/100 minus 387 9/10. Let's show the work for this. We know that the first step we want to do when faced with a subtraction problem that looks awkward like this, we're subtracting a bigger number than we have. So let's play add ops. And now we know that the sign of our answer will be negative. We have more negatives than positives, and we have to subtract because the signs are different. 387 9/10, 26 54/100. You'll notice that I lined up the decimals and all of the place values. We can put a placeholder 0 in here. 4 from 0, can't do it. 4 from 10 is 6, 5 from 8 is 3, 6 from 7 is 1, 2 from 8 is 6. Negative 361 36/100 is our answer. Number 2, there were 3 2/3 pies left in the kitchen. So 3 2/3 pies. Mr. S got in and went wild, typical. When there's pie, I can smell it. Then there was 3/4 of a pie left. So 3/4 left. How many pies did Mr. S eat? Okay, so we're going to see how much did I eat. Well, I didn't eat all 3 2/3. I ate almost all of it, but we have to subtract out what was left. So in this case, we're going to subtract. We'll say 3 2/3 minus 3/4. We know that we need like denominators, so we can say this would be 3 and 4. These two denominators go into 12ths. So we multiplied this bottom number times 4, so we need to multiply the top number times 4, and we'd have 3 and 8/12. That's an equivalent mixed number. And this bottom number we can multiply by 3, so we need to do the top, multiply the top by 3 to have an equivalent fraction. This would be 9/12. Now I can't do 3 and 8/12 minus 9/12 right away because we don't have 9/12 to take away. This is a common mistake. People will just try and say that's 1/12. But you can't take 9/12 if you only have 8. So let's trade in one of these here, 3 full units, and we can get 12/12 out of it. So now we'll just be left with 2 full units, but we got 12/12 to add to our 8/12. That's 20/12. Now we can subtract 9/12, and we'll be left with 2 and 11/12. So he ate 2 and 11/12 pies. It was a slow night for me. There we go. That's the work I expect you to show. Here are the questions I'm going to leave you with. 5 2/5 plus 2 5/6. Remember what you'll need there. And then number 2, the temperature of a mixture is negative 12 3/10 degrees Celsius. After another liquid is added, the temperature drops. The temperature of that mixture drops 8 86/100 degrees. What is the new temperature? Best of luck. I will see you soon.